Okay, 6th period Algebra 1. In this video, I am going to help you finish your notes for section 1.2.5 on domain and range. And so what I want to do is just first take a minute or two to review some of the big ideas we talked about in terms of domain while we were in class together. So if you take a look right here in this middle section, this is where we started to talk about that idea of domain, and we went through and evaluated the function in the function machine for different inputs, -3, 0, 2, and 3. And what we found was that when we had an input of +3, it didn't work. Everything seemed to be working just fine until we put 3 into the function machine. And then we ran into a problem because we had 0 in the denominator, and we had a nice discussion in class about why we can't divide by 0. And so we said at the input of 3, this function is undefined, meaning the function machine does not understand an input of 3. It's like putting Monopoly money into the candy machine. It doesn't understand the input, so it can't give us an output. Okay, and we said there was no other input that would produce that situation. An input of 3 was the only one that wouldn't work. And from this, we came up with our definition of what a domain is. The domain is all x values that we can use as inputs. So we said for this particular function, the domain was all real numbers, every number that you're used to working with, except x equal to 3. That's the one that won't work. We also had a quick discussion about other types of functions we've worked with that also have limited domains. And we said the square root function is one that has a limited domain because we can't evaluate a square root of a negative number. So whenever we simplify a square root and there's a negative sign underneath the root, it won't work. It's undefined as well. Okay, so what is the range then? Well, first let's take a look at this function that's drawn off here to the right, g of x. And we're going to first take a look and decide if g of x is a function or not. Remember, if we're looking to see whether or not it's a function, we need to check and make sure that every input gives us the same output all the time. Okay, we need to make sure it's being predictable. So I'm going to do this using the vertical line test. Here's my vertical line, and I'm looking to see that all of my inputs always give me just one output. In other words, will this vertical line always cross the function just once? And we can see as I move it through back and forth, it does. And so g of x is a function because every input always goes to the same output. How can we describe the domain of g of x? Well, what I'm going to do is I'm going to highlight my x-axis because domain are the x values that my function is able to use. And so what we want to do is read the graph from left to right and notice where do we start using x values. So if I'm looking at my graph from left to right, my function starts appearing right here, okay? And then it curves up, curves down, and it stops right here. At those start and stop points, what x values am I using? Well, I'm starting right here at -2 and going all the way over to +4. So how can we describe that domain? Well, it's all x values from -2 to +4. If the domain is all of the x values that we are allowed to put into a function, the range is the set of all the y values or outputs that the function is able to give us. How can we determine the range from a graph? Well, again, I'm going to highlight an axis, and it's going to be the y-axis now. Okay, and just like with the x's, we read it from the negatives to the positives, left to right. With the y-axis, we're going to read that graph from the negatives or the bottom up to the top. And we're going to take a look at, again, the lowest point now and the highest point. If I start reading my graph from the bottom up, where's my lowest point? It's right here at y equals a -1. And if I continue reading my graph vertically, where's the highest point? It's right here at +3. So we would say the range of g of x is all y values from y equals -1 to y equals a +3. The mystery guest in this video is Captain Crunch. Now in part D, it wants you to think about the following question. Ricky thinks that the range of g of x is -1, 0, 1, 2, and 3. Is he correct? Does that fall in line with how we just described the range of g of x, all y values from -1 to +3? Why or why not? So you're going to notice that in this assignment tab, there's a quick Google form for you to fill out based on this lesson video. And one of the questions is to have you answer that. So I'm going to have you answer that in the Google form, and then we will have a quick discussion about that when I see you in class next. Okay, on to the next section. We're describing in words the domain and range of each graph below, and then stating whether or not the graph is a function. So first, let's take a look at the first three here. I'm going to do these with you, and I'm going to have you try D, E, and F on your own. So here's a vertical line. We're going to do a quick test of these first three to see if they are a function. Okay, the first one, remember we're looking for, does this vertical line intersect my graph more than once? And as you can see, as soon as I start getting into the function, absolutely, okay? I have a bunch of places where I'm intersecting my graph at 2 different times. For example, right here and right here. This is not a function. If we use our vertical line on the second graph here, we can see that it always intersects that graph just one time. So this second graph is a function. And if we use the vertical line test again on C, we will see that, again, it only intersects at one point as I move that vertical line through the function. So C is also a function. Again, I'm going to have you decide whether D, E, and F are functions or not in the Google form that's attached to this assignment tab. All right, now our job is to go back and decide what would best represent the domain and range of each graph. So I'm going to start highlighting axes. For A, if I'm looking at the domain, those are my x values. So I'm looking just at the x-axis. Where on the x-axis, if I read it from left to right, does my graph start? Well, the first x value is right here at a -3. And as I keep reading my graph, the last x value I use is right here at a +3. So my domain is all x values from -3 to +3. If I want to figure out the range of this function, I need to concentrate on the y values. So now we're looking from bottom to top. Where do I start using y values and where do I stop using y values? The lowest y value I use to make my graph is at a -3, and the highest y value that I use is a +3. So my range is all y values from y equals a -3 to y equals +3. In the second graph, if I want to find my domain, I'm going to look at my x values and read my graph from left to right. Where do I start using x values? Well, the one thing I want you to remember on this graph is that the arrows on the end indicate that this graph continues on forever in both directions. So even though the picture of my graph stops on the page, those lines continue forever towards infinity in both directions. So really, on either side, I'm continuing to go to the right with my graph towards infinity, and I'm continuing to go towards the left with my graph towards infinity. In this case, I'm really using all of the x values on the number line. How do we write that? Well, any number line that we use represents every real number, every number that you've ever known and loved in your entire life. And so we simply say that the domain is all real numbers. You could even say all x values from negative infinity to positive infinity. And similarly with the range, if we take a look from top to bottom, because on the left that arrow keeps making the graph go down, 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 and because on the right the arrow keeps making the graph go up, 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 our range or the y values that this graph uses are from negative infinity to positive infinity. Even though the picture stops, we have to recognize those arrows, meaning the graph keeps continuing on forever. In the last graph here, C, what's important to notice is that instead of arrows, we have endpoints on that segment. And that means it stops. What we see in the picture is what we get. It's not continuing on forever. That changes how we analyze the domain and range. If we take a look at the x values and read our graph from left to right, now the first x value that I am using appears to be at -2. And if I keep reading to the right, the very last x value that I use is at +4. So my domain is all x values from x equals -2 to x equals +4. And for the range, if we look at our y values and focus on reading from bottom to top, the lowest y value that I use is here at a -4, and the highest y value that I use is at a +2. My range is all y values from y equals a -4 to y equals a +2. Okay, so what I'd like you to do now is I want you to focus on trying to figure out whether D, E, and F are functions or not, and also try to come up with the domain and the range for each of those functions. You are going to answer those questions on your notes worksheet, but also in that Google form that's a part of this lesson tab. If you have any questions, please let me know, and I will see you in class in a couple days.